So you add like the number of electrons you're going to get to 8 by 1 here, 2 here, 3 here, 4 here, because the electrons is going to be -1, -2, -3, -4. So that's how you predict the charges. Okay? So we go back to this. That's why we know chlorine is -1. That's why we know sodium is +1, and we get sodium chloride. Okay? The first example we have in our script says, what happens when N and K react? They want to know what is the ionic charges, the formula of the compound, and the name of the compound. So that's what we're going to be doing with sodium and potassium. All right. So let me back up here. Now again, notice that the positive ion is always first and the negative ion is always last. It doesn't make a difference what order this comes in here or this comes in here. We have to write the formula so the positive ion is first and the negative ion is second. Very important. Okay, so we go and find nitrogen on the periodic chart. Nitrogen is a nonmetal, and it's in group 5A, so it needs 3 electrons to be full, so that's a -3 charge. So let's put that up there. Put it in red. -3. So that's not going to be the first thing mentioned here. Potassium is a metal. It's over there, just like in sodium, hello, where it's in group 1A again, so that's a +1 charge. Okay? So, this will be +1. When we combine those, K and the N go in that order, Kn, but all compounds rather must be neutral. They must add up to 0. -3 plus 1 does not add up to 0. In order to fix that, this has got to have 3 positives. How do we get that? Well, that's from 3 times the charge of +1. So that means we have to have 3. Oh, jeez. Oh, my word. That means we have to have 3 potassium. Now, how do we write that in a formula? We write that as what we call a subscript. So that means that 3 goes down over here. And now we have -3 plus +3 equals 0. This is the name, or this is the formula of the compound. And the name for that, well, if you write it like the way it looks, this is potassium nitrogen. But, and there's always that big but, it has to end in I in order for the element to have to be shown as a negative charge. So like I said, the English language doesn't help us at all in figuring out what this is going to be. You just kind of have to learn it. There's a few little tricks to that, but in this particular case, we drop the O-G-E-N and put I there. So the name for that is potassium nitride. And the way that I always remembered it when I was a first-year chemistry student was nitride and nitrogen. Okay, got it. All right, one more example we have in our script, and that deals with the reaction of magnesium and phosphorus. So we have to identify what's positive, what's negative, so we go back to the periodic chart. Okay, so magnesium is over here in group 2A, so it's going to have a +2 charge. And phosphorus, we'll find that vein. Phosphorus is right below nitrogen here. It's a non-metal, 5A. So it's going to need 3 electrons in full, so it's going to be negative 3 charge, just like nitrogen was. So let's go do that. So if we put Mg and D together, we do not have a total of 0. Nor we have to have a neutral compound. Well, this is one of those deals, since we can't have fractions in the subscripts, we can have them in coefficients, which we'll talk about later on, but not the little numbers that go by the atoms. So that means we're going to have to do something for both of them. So we treat this like fractions that have denominators of 2 and 3. Find the lowest number that 2 and 3 go into, which is 6. So if I want to make this 6, I'm going to have to multiply this by 3. That gives me 6 positives. And if I want to change this to 6, I multiply this by 2. I hate this board so much. I really hate this board. Times 2 gives us negative 6. 6 and negative 6 equals 0. So that means this 2 will go as a subscript 2 right here. And this 3 right here is going to go as a subscript for magnesium. So that becomes Mg3P2 as our formula. Name, well, we write it down as they appear. It looks like magnesium phosphorus. But in actuality, what we're going to do with this is we drop the ORIS and put IDE. So the name of the compound is magnesium phosphide. So there you have it. Charges, 2 is negative 3, formula Mg3P2. And magnesium phosphide is the name of the compound. Your practice problems. Give the charges of the ions, the formula, and name of the compound created when the following elements react together. And there will be 4 answers for every problem. All right? Good luck.